Feel free to stop me and ask any questions. But real quick, how many people have used Terraform by a show of hands? Okay, so pretty good chunk. So this may be a little like overview for you. Feel free to ask questions, but I'm hoping that I will be using a provider that most people might not be aware of or have used, so you can see kind of how that works. But generally, Terraform, let me make this full screen quick. Size good there. So really, Terraform is an infrastructure as code tool. Oh, did you switch over, John? Sorry, to the presenting? No, I'm just wondering, because for the stream, are we good? Okay. So yeah, Terraform, it's an infrastructure as code tool by HashiCorp, and it's based on a declarative language called HCL. And one of the unique things that Terraform kind of has going for it is you can really do multi-cloud deployments or providers, and really just any service out there probably has a Terraform provider. And you can look at the registry, which I'll show here in a minute, just to see all the different flavors of things that you can use Terraform to interact with. So if you want to install Terraform, there's the website. You can go to terraform.com and get that. If you're on Mac, it's brew install Terraform. Windows, if you're using Chocolatey, you can do Choco install Terraform. When would you want to use Terraform for your IAC tool? So you'll see a couple other tools tonight. Terraform really excels at kind of the complex dependencies, multi-cloud setups. So if you have something that's in AWS, Cloudflare, inflow blocks for DNS type thing, Terraform can just manage all of that. The other cool thing is it doesn't even have to be a cloud provider. Like VMware also has a provider, so you could do stuff on-prem as well and manage your infrastructure in your own data center. And then another benefit that I find with Terraform is they have a very good state management system. So if you need to make changes to your infrastructure, you can basically apply that, which I'll show. So you'll apply your infrastructure changes, and then there'll be a state created for that. And if any changes or anything happens behind the scenes outside of Terraform, Terraform can detect that, and then you can go through and kind of fix that. I did actually another talk, which is on YouTube, about Terraform importing resources. So if you've created all of your infrastructure outside of Terraform, manually in the console, like in AWS or whatever, there's ways to import that back into state. So there's a lot of cool things there that you can do. But generally, what are the key concepts that Terraform has? So like I mentioned, providers, these are just plugins where like a developer for that company or service, they would create your Terraform provider. Really what that's doing behind the scenes is interacting with some kind of external API for that service. And then resources, so all of your infrastructure components like servers, DNS, S3 buckets, that type of thing, they're defined as resources, resource blocks, and then they take different arguments, which you can find in the documentation. So really anything that you need to build in a cloud or however other resources are set up, they'll be defined as arguments. And another kind of like power user tip or whatever with Terraform is you can create reusable modules out of a collection of those resources. So if you have a certain way that you want an S3 bucket that's compliant with like versioning on, encryption, those types of things, you could just create a module and then share that across teams or with just other teammates as well. And then like I mentioned, state, so that just creates a single source of truth for your infrastructure. And then you can ensure like as you do a deployment for your infrastructure with Terraform, you have a known good state going into it or whatever. So here's just an example of what setting up a provider would look like. And if we go to the provider website here, you can see there's just tons of different providers. So like there's AWS, Azure, Google Cloud Platform. The one I'm going to be using tonight is Cloudflare to create a simple website. So if we just look at Cloudflare, a lot of these, one thing that I realized, I've not actually used the Cloudflare provider until yesterday. I had just assumed a lot of the resources were defined very similarly across providers. So that's one thing that you'll learn is each kind of provider does their own thing. There's not a lot of consistency, so that's one probably downside to this, but you still have the flexibility to just use one tool to manage all these different things. So, so in my case here, this wasn't the right slide. Where did it go? That looks different. 1 second, sorry. That's old. There we go. Yeah, so this is what like the AWS provider looks like. Even the providers themselves, they could be considered resources, but this provider block here, I'm defining like the AWS region as US East 1. Cloudflare, really all they take in their configuration is just how do you connect to me, and you don't even need to really define that either. You can just use like an environment variable or something else. One thing also to mention is this, you can have specific versions of providers. So if you want to use an older version for some reason, you can define that here, and then that will basically lock you into that version as you're doing your deployment. So that can make it more immutable, so that way if there's changes to those providers, you're not just taking them in and then your deployment breaks the next time you run something. So that's another kind of best practice, is make sure that you're pinning your versions of your providers. So to use Terraform, really it can be broken down into 3 things. So I'll show you what it looks like to have some different Terraform files, and then Terraform planning. So what does that actually do? That will show you the different changes that will either go into be getting deployed or the new resources created. There's a lot of information in there, so I'll kind of break that down really quickly. And then to actually do the deployment, you'd run Terraform apply. So yeah, let's just jump into here. Are there any questions right off the cuff here? Okay, so I'm going to just go into my Terraform directory in my command line. Is that size okay? No, it's not. Let's make it a little bit larger. That should work. Okay, so what I have here, and you can go to, it's on GitHub, just do my last name, Tessman Jonathan, cf-terraform-talk, and you can get the same repo here. So what I have broken down here is this is our website. This is actually just the DevOps Des Moines website. And my Terraform folder here, I have just this is not a module, so this is just all of the resources for setting up the Cloudflare provider, which is right here. This is actually old. Let me pull down the latest one. Git checkout main, git pull. There we go. Okay, so slightly different than what I was expecting. Okay, so here's, let me go back. I'm going to go back to the talk one, git checkout demo. Okay, so this is what it looks like without a module. So I just need to fix one thing, but we can do it live here. So a lot of times, basically inside the directory of Terraform, you can call it whatever, but I just, as a standard, a lot of people will call it Terraform. You'll have a main.tf file. That can be named whatever you want. It doesn't have to be main.tf, but that's just kind of like a common standard to use, main.tf. This will define your resource, and the resource I have here, which I found on the documentation, is called Cloudflare Pages Projects. And if I go look at this documentation quick, Cloudflare Pages Project Resource, then this is kind of where you can find an example and know what different resources or arguments you can use. So in this case, they have kind of 3 main components to a Cloudflare page: your source, which is integrated with GitHub. So this is pointing to my GitHub repo for this talk. The build configuration, so if you have, like if you're using Vite or something, or a React app, and you need to actually build your application. In this case, I just have static index HTML, so I don't have to have a build command. That's where you could add this. This is just the directory of what I'm publishing. And then deployment configuration, so this tells me just a few different things. So like I can set environment variables on the actual deployment itself that could be used at runtime. Some of the cost usage stuff, and then smart placement, that's just like the default value, so that's what I left it as. And some other things that Terraform has are data sources. So within the Cloudflare provider, there's information about my account that I need in order to successfully deploy. So I just created a data source here called Cloudflare accounts, and that's gonna just look up my account, get some information, and then like later on I'm using my account ID here. So I don't have to have that value set in any type of configuration. I'm dynamically pulling that from Cloudflare. Another good practice is to set variables as well. So this one I don't need anymore, so I will remove that. I think I'm probably going long, but we'll just keep going really quick. Inside here, I'm gonna set this provider. Where are you at? So I don't need that. I've already set up my credentials in my environment, so I don't need to pass in the API token to work with Cloudflare. Another example, like with AWS, is you can do like AWS configure and get like an IAM user or something added that way. But here are different variables that I'm using. So I'm using the account name, which is the Cloudflare account. So think of that like an AWS account. Project name is actually what the page project's going to be. This is the information about what GitHub repo you would pull the content from. And then outputs, this just shows you, after you run your apply, other resources or other modules, if you want to call it that. This isn't a module right now. Could use these output variables to then do something else, like set a DNS record, or I don't know, like update something in an S3 bucket as an example, or upload something into an S3 bucket. So what I'm going to do now really quick, let me just clear the screen. I'm in the Terraform directory, so to start off like installing the provider, I will run Terraform init, and what that's going to do is it's going to reach out to HashiCorp's registry, pull back that provider information. That's really all it does, and then it also created this lock file, so then now I know this is exactly what I'm going to get for provider every time when I run that command or run this deployment. So then if I do Terraform plan, that's the next step. Account name, so I don't have a variables file. That's another thing you can do, is you can pass in variables, so I'll just type this out. GitHub owner name, my last name, CF Terraform talk. And then now what it just did there, and I'll try to make this a little bigger. So it asked me for the variables. Here it's reading from that data source my Cloudflare account. And then this is just an indication that what it's going to do is it's going to create my static site. So here's all the properties and all that. This is all being added new. And then you kind of get a summary as well, oops, that says I'm adding one resource, nothing is changing, nothing is going to be destroyed, and then these are what the outputs would be. So the other cool thing about the Terraform commands is it tells you kind of the next thing to do. So here it's saying if I want to actually apply these changes, I would run Terraform apply. I just want to show really quick on my Cloudflare account that I currently do not have any pages set up. Once it finishes refreshing. One other reason for the demo that I chose Cloudflare is it's completely free. Like, I like that I didn't have to put any credit card or anything in here, and then it's just gonna run and do everything I need. And for the most part, it's pretty simple to work with. So here I've got no page set up. So if I run Terraform apply, I've got to put these values back in here. That is CF Terraform talk. And yes, I want to apply. So that just kind of showed the same thing as the plan. So now it's going to be creating my project. So if I go back out to Cloudflare here, go into workers. So I've now got a Pages project. One thing that it does not do is it doesn't actually do the deployment of the app. However, how this is configured with Cloudflare is it's monitoring my GitHub repo. So if I make a pull request into it like this, which I'll try to do really quick, /cf talk. So let's just make a quick little change on our DevOps Des Moines website. I will say, we'll just change the title tag, hello demo, or I'll just do hello world. Commit changes, do a new branch, create pull requests. So what you could also have set up with this is previews on the Cloudflare pages. I don't have that, I'm just having it going off my main production branch. So once I merge this in, let's just do one other. I want to grab the URL that it is going to use. So it's this one. So if I go here, before I actually do the deployment, I want to show this not working. So, well, it just created a deployment already. So, yeah, that's generally how quick like this stuff works. Like as soon as you create a pull request, it's going through and doing that. It may already, I'm actually kind of a little surprised by that, but I might have something misconfigured here. But yeah, so essentially with Terraform, I was able to create a quick little static site. You can see it's actually the old version, so this should actually be updated to say hello world here in a second. I might have to do incognito. There's hello world. So there, just did an update off the deployment. And then if you, for whatever reason, need to get rid of everything like you're doing a demo, so oops, you can't see that. Let me just clear the screen really quick. Terraform destroy, that can just clean up everything. It wants all of this. Testman, Jonathan, CF, Terraform, talk. So an alternative to not having to type all those in, what you can do is you can create a TF-vars file. So like at this level, I could say terraform.tf-vars, and then I can just put in those values that it's asking for, like GitHub owner. Where's it at? TF-vars equals Testman, oops. Testman, Jonathan, and then, yeah. So I'm kind of over time, but I think we'll be okay a little bit. I just want to show one other thing that I mentioned is the modules. So what this looks like as a module then, this little thing's in the way. So if I do git checkout main, and I won't do the deployment, but git stash. Okay, so we got our update there. So what this looks like as a module versus the individual just resource definition files. So kind of standard to create a module directory and call it modules, and then a module is just a folder within that directory, and you could have Cloudflare page, you could have S3 bucket, you could have a number of things, and then any number of really .tf files in there. So like in this case, the only difference that I've done now with this as a module is I've created a few more variables to try to make it a little bit more reusable. So like I've added the GitHub branch if I don't want it to be on main. Maybe in this case I'm not doing a static site and I need that build command or a different application directory. And then in order to use the module, I'll just go back to my Terraform directory inside here, and you can see it simplifies a lot, and then I don't have to worry about some more of that complexity. So this is how you would reference a module. You would say module as a block. You can call this whatever you want. This is just the resource identifier here, or the module identifier. And then this is the source, so that's pointing to my local directory, Cloudflare page module. You could have this in a Terraform registry, on GitHub, Artifactory, whatever. You can pull those things. And then these are just all the variables that I've defined for this one. So running this one just makes it a little bit easier. But are there any questions? Otherwise, I'll switch over to the next one. Go ahead, Matt. Yeah, so
Is there that standardization across providers?
I don't know if there's standardization. So the question was really about comparing Terraform to CloudFormation, where CloudFormation documentation will give you very declarative, like if you update this property, it's going to delete and change the resource. Another thing with CloudFormation is you can generate change sets. I think of change sets very similarly to that Terraform plan step. However, on that Terraform plan screen, it's not going to tell you if it's going to cause a replacement. It really just depends on the provider. So like in this case, Terraform or Cloudflare, I don't think they're very mature with their Terraform provider. They actually have their own CLI. And what I would say is, back to the whole question of should you use Terraform for your use case, if you're just doing a simple page like this, probably don't use Terraform, what I found, and just stick with their Cloudflare API CLI tool. But yeah, so like AWS, I think the Terraform provider for that kind of tells you like, hey, this is going to be modified, this is going to be changed, this is going to be replaced. So you do get that with the AWS provider, but not all of them. So, man.
I hear Terraform changed their licensing or something like that, and people are moving over to OpenTofu.
Yep, that's a really good call out.
Yeah, do you know if there are challenges for switching over, or is it mainly pretty seamless?
For the most part, they forked the original Terraform code a while ago. So as far as I know, there's feature parity across them. The other thing I've heard, and I don't know how valid this is so HashiCorp is the company that owns Terraform or bought Terraform, or no, they created Terraform initially. They got bought by IBM, and IBM might be moving it back to open source. So there is a potential that Terraform might be going back to open source. Again, don't quote me on that, but like if you think about it, IBM has Red Hat, which is open source, a few other things. So it may be coming back to open source, which I don't know if they've seen like challenges or like competitors with OpenTofu, and that's why they're doing that. But yeah, so that could be something. But yeah, so if you do want the open source version of Terraform, it's called OpenTofu, and it should be pretty compatible. All right, well, Eric, you want to get mic'd up here? I will stop sharing.
What do I got to do? I'm connected to the meeting. Do I just share in the meeting and that's it?
Yep, that's all you got to do. I will stop sharing if I can find the button.
All right. Right in the mic. All right. Okay. Oh, did you just have a mouse connected? I was like, oh, they're cables.
You want all this?
No, I'm good. Thanks, though. Let's start sharing here. And I think I'm just going to share my whole screen. Yay. All right, so my name is Eric Rasmussen, and I also work here at Source Allies along with Jonathan, and I'm going to be talking about Pulumi. So in case you're not familiar with Pulumi, it is incredibly similar to Terraform. In fact, they're like direct competitors. So it's really good that Jonathan went first. If you're not familiar with any of this, we can compare and contrast a little bit easier. Pulumi is pretty much the exact same thing in functionality. It's an infrastructure as code provider. Its gimmick, per se, is that it lets you define your resources using your favorite programming language instead of Terraform's proprietary HCL. It's not proprietary, but their custom HCL, the DSL, domain-specific language. Pulumi lets you author your infrastructure in TypeScript, Python, Go, C#, Java, and even YAML in case you just really love YAML or you really hate all of the other options. So one of the benefits of doing it this way is that if you're coming from more programming-oriented background, it lets you start getting into DevOps stuff with tools that you're already familiar with. In addition, Pulumi has a similar concept of providers. They call it the same thing, which is really nice. And these providers can also be shared via your favorite package management tool. So if you really like NPM, you can share infrastructure providers via NPM. Same thing for Go modules, C# NuGet packages, whatever the heck Java does. Who writes Java? And YAML you can share with Git repositories, which is pretty cool. Beyond that, it's, like I said, almost exactly the same as Terraform. All these are basically just fancy wrappers around CRUD operations calling APIs. So Pulumi's no different. It's doing the exact same thing. If we go over here, we can see they have their own registry. So same as Terraform, same as Jonathan was showing. They've got the major cloud providers here, and they've even got a whole thing you can search for all the stuff here. One of the things I think Pulumi recognized is that Terraform is pretty darn good, and people are not going to want to move out of Terraform unless they have a pretty good reason to. So what Pulumi has done that I think is kind of cool is that a lot of their providers are actually wrappers around Terraform providers. So Pulumi has essentially leached the Terraform provider code and used it to offer Terraform providers in Pulumi workspace. So, and it's actually kind of hilarious. One of the more notable examples of this is the Cloudflare provider from Pulumi. So we can see it's on the registry. You know, we can add @Pulumi Cloudflare. We do the same thing. But if we go over to the code base, there is a decent amount of code in here because this is an older one, but ultimately this is just a wrapper around the Terraform provider. So all of the code in this repository is not doing any Cloudflare specific stuff. So that's another benefit that Pulumi has is that if you're deciding that Pulumi is the thing to do and you're like, ah, crap, well, I don't have that provider that I'm using in Terraform, turns out you can just consume the Terraform providers from Pulumi. And to add another layer to that, they even have a Terraform provider now, which is pretty cool because it will do code gen in your local directory, local repository, to consume providers that Pulumi does not develop wrappers for. So it essentially generates a wrapper in your local Git repository that you can version alongside all of your other code as well, which is kind of cool. And then today, what I was going to hopefully demo, and hopefully it goes well, I was debugging this just in the past hour, so we'll see how well it goes. But I was just going to show a small example of using Pulumi to spin up a kind Kubernetes cluster on the local machine and then deploy a simple little BusyBox pod to it. So I've got just an empty VS Code workspace here. Pulumi's got a CLI, so similar to the Terraform CLI. I've got an alias to P, so it's just kind of muscle memory that I type it, but it's Pulumi, and it's got a whole ton of options and stuff like that. It's, at least in my opinion, it's a little bit more user-friendly than the Terraform CLI, but that's perfectly personal preference. Some people probably like the Terraform CLI more, but that's one thing that I think Pulumi has a benefit of. So we'll go ahead and we'll just create a new project here, and I happen to like TypeScript. I think it works nice as a configuration language while also having all the features of a general purpose programming language. So we don't have to do TypeScript, we could do any of the other languages, but that's what I'm going to choose today. And let's just click through all the things. Pulumi has, oops, I was doing this earlier and I didn't delete the stack. Pulumi, also, so if you're doing TypeScript, you can also choose your package manager too. So if you like NPM, you can do that. If you like PNPM or Yarn. More recently, I think it's literally within the past month, they added support for Bun, which for some reason isn't working, but it's new, so that's fine. But we'll go ahead and just choose Yarn here and get a project initialized. So it created a whole bunch of stuff. And then, as I was going to say, but interrupted myself, Pulumi also has a similar concept of Terraform of stacks. I think Terraform calls them, is it also stacks? I forget. I don't do Terraform much, but Terraform's got a similar concept. Maybe stacks? Okay. I'll look really quick. Sure. I think they're more of a first-class citizen in Pulumi than they will be in Terraform, but it's the same feature. Both tools can do the exact same thing. So now it'll have initialized just some very bare-bones stuff. They've got their own little configuration file. Where Terraform, most of your files are in the TF, the HCL syntax. Pulumi will use files that are pretty familiar for the programming language that you're working in. So like index.ts is pretty common to see in a Node code base. And you got your package JSON as well. This is where you'll declare your dependencies. So nothing new if you're familiar with the Node stuff. And then we even have a TS config. TypeScript is first class. I think you probably can do JavaScript, but I've never tried to. And I don't know why you would. So over here in the index.cs, we can't do really much right now because we don't have any providers. So let's add a couple, and we'll just add them with Yarn. So we'll be pulling in the command provider, which I'll talk about why in a minute. And then we'll pull in the Kubernetes provider, the two that we'll be using today. And I was going to do this in Docker, but last minute stuff, it wasn't working, so I scrapped it. And we're instead going to use kind via the command package. So if, again, you're a user of Terraform and you're familiar with the dynamic providers, or what do they call them? I'm blanking on the Terraform terminology, but it's like you can run a command during your deployment effectively. And it helps you, with awkward initialization steps that whatever resource you're deploying might have. The command provider sort of attempts to fill that gap. So what we can use it to do is to run just basic CLI commands and have them act as if they were resources. So we can do creates, updates, and deletes. So we'll first create a create cluster resource. This is where we'll run our kind command. And then we will create a new command. And actually, this is going to be here. Let's just do a fancy little import up here, just to make this a little bit easier to type out. And I can't type. We'll get Pulumi command, and while I'm up here, we'll just also import the Kubernetes provider for later. There we go. And now we'll do a new command, and then we want a local command. You can also use this to run like SSH commands on a remote machine if that's something that you need. But we're just going to do a local command, and we'll call it create, because it doesn't really matter. We're not going to have a ton of resources. And for the arguments to this create resource, and let's close this too, basically we get our CRUD operation. So we have our create, we have our update, and we have our delete. And there's some more stuff here, not relevant right now. But we will be doing the create and delete. So in here, we'll just do, like we're in the shell, we'll do kind create cluster, and that'll create a Kubernetes cluster. And then in case I mess things up, we're going to delete it on destroy as well. And awesome, we can get a Kubernetes cluster now. In order to deploy things to it, we need the kubeconfig. So let's go ahead and get the kubeconfig, and we can use another Pulumi command to do that. So we'll do local command, we'll call it get kubeconfig, and we'll do the similar thing. We'll give it a create, and what this is going to do is just kind get kubeconfig. So that's how we'll get the connection credentials in order to connect to our cluster that this thing just created. So similar to the provider block in Terraform, we can also instantiate providers in Pulumi. So we can do const provider equals new, and we want to create a new Kubernetes provider to connect to the cluster that we just got. So we'll call this DOD for DevOpsDSM, and we'll give it the arguments, and all we have here is just the kubeconfig. So we need to pull that value out of the command. So we'll do our get kubeconfig, and this is just as if it were a command resource in your favorite programming language. So we have standard error, standard in, standard out. So if this all went well, it should be on standard out. So we'll pass that as our kubeconfig. And finally, let's just create a simple little pod to prove that things are working. So we'll create a new Kubernetes core v1 pod. We'll just name it test. And I was actually having issues pulling images earlier today, so hopefully this works fine. Metadata, we'll just put it in the default namespace. You can omit this, it'll automatically go there, but we'll type it out just to be explicit. And then finally, we just need to give it a container to deploy, so we'll go down here. We'll give it a containers array, and we'll just deploy the Nginx container. I think I said BusyBox earlier, but I'm going to see if this works. BusyBox wasn't for some reason. I'm not sure if it's related to the image or something else, but boom, all of that, and we have a stack that we now hopefully should be able to run. So let's give this a go and see if it works. So first, we'll kind of compare some of the Pulumi commands. So we have preview is very similar to plan. It effectively does the same thing. So we're going to preview our update, see what it thinks it's going to do. Hopefully, it's all good. We can ignore that warning. Everything else seems fine. So it's telling us that it's going to create a new command. It's going to create a pod. It's going to create these two tasks, these two command tasks that we have. And then it's also going to create this Kubernetes provider. And I just remembered something. This is going to break unless we specify dependencies. So obviously, doing infrastructure as code, you have things that depend on other things. Terraform has, I think it's depends on is the way you would do that. It's very similar in Pulumi. In fact, it even has the same name. It's just in a little different location. We have an extra little options box down here where we can pass our depends on. So we won't do it for the first resource, but we will do it for this second one. Go over here. This is going to, oops. This is going to depend on the create cluster command, and we got to give it colon in there. There we go. And then the provider, let's see. Oh, just kidding. That doesn't take dependencies. The pod, the pod is going to use the Kubernetes provider. There's another thing I forgot. We got to tell it which provider it's using. And it's also going to depend on the get kube config, because that has to work in order for us to do anything with pods. So, okay, now back over here, and let's make that full screen. And to deploy, Pulumi calls this up. I think it's alias to deploy as well, but we'll do a Pulumi up, and hopefully this should create a kind cluster and deploy to it. Oh yeah, first it's going to ask me, am I good with this? Yes, I am. So let's go ahead and fingers crossed. So right now it's just logging the output of the kind create cluster command. So you can kind of see that happening in the little below the warning down there. It's a little small, but let's see, can I? Maybe that's better, I don't know. Now it's all messed up. All right, there we go. So it's created the cluster, it's fetched the kube config, and now it's trying to schedule a pod on this new cluster that we just created. So kind takes a little bit to start up after it's, the CLI command is exited. So currently kind is finishing spinning up here and it's failing to schedule, and now kind has started. So it's attempting to create that pod, and then like I was saying earlier, I'm having some weird issue with image pulling, but basically it did everything that it's going to do today. If my machine was letting me pull Docker images, it would have just deployed the Nginx container here. But just to kind of prove it out, let's go over into another terminal, and that's way too small. Just kidding, we're gonna go back here. And let's just do kind get clusters. We see we got a kind cluster going, and then if we do kubectl, alias is all over, get pods, we can see that we have our little test pod running over here. So we just use Pulumi to deploy a whole cluster and put a pod on it. So boom, there we go. This talk was very last minute, so that's all I've got for you. So any questions? All right, Joseph, off to you.
Go. Okay, so my name is Joseph Milliken. I'm also here with Source Allies. I work with those two fellows also. And I'm here to talk about AWS CDK. Now, it is similar, but not the same as Terraform and Pulumi, mainly because it is targeted toward AWS. So first thing you're not going to get is you're not going to get all of the different support for all the different cloud providers, but that's also part of its strength. So we already know infrastructure as code is great. I'm literally not going to go through this because they already talked about why it's so great. Reusability, environments, productions, all that fun stuff. But sometimes it's not great to work with. So sometimes it can be difficult to write. As fun as it is and powerful as it is to learn these templating languages, you still got to learn a unique language, a specific DSL. And with some of them, there is limited modularity. Pulumi is solving that, of course, by allowing you to use any language. You'll see CDK will allow you to do that too. But there's also the, does it work? Well, we sure hope so. We're just going to deploy it to dev and find out. Without it being as real code, it's hard to do that. So what did AWS CDK do? They made it just code, right? Similar to Pulumi. You can write it in your, your favorite programming language. So Java, Go, TypeScript, Python, and C#. You name it, you got it. Since it's just code, you can also use your favorite package manager. whatever Java uses, again, someone programs in that. Go, TypeScript, NPM, NuGet, pip, UV, all of them. And again, since it is just code, you can add your test that you're already using to enhance it and to assert, yes, that is the infrastructure that I wanted to generate as code. But what is it? Well, they define themselves as this. I'm not going to read that aloud because that is how every software defines itself. What's that mean, though? It means you define the infrastructure in your favorite language. You use constructs of various detail, L1, L2, L3. What that basically means is that they've prepackaged a lot of convenience at the highest level. It does all the things you want, a little bit of customizability. At the lowest level, L1, you're basically writing raw templates. And then once you do that, it generates it, and it auto-magically, my favorite word, deploys AWS CloudFormation templates. But what is a formation of clouds? Well, that is another infrastructure as code solution that AWS has. That, if you look at the words here, it looks like it just said the same thing. You don't need to worry about it. What AWS CloudFormation is infrastructure as code templates. It's just templates. So you're defining a YAML or a JSON template, and AWS will deploy that, manage it, do all the fun stuff on that. So where CDK really is powerful is that it's on top of CloudFormation. So all of the great things that CloudFormation brings, which is a lot, it's just added onto with CDK. So actually getting into it, it's relatively easy, much like Terraform, much like Pulumi. You just install it, and then you initialize your application, which is what I will do right now. So make a demo directory, not look at the spoiler code, and initialize up a new TypeScript instance. Cannot be ran on an empty dictionary. It would help if I CD'd into it. So you initialize it. Again, I also think TypeScript is pretty cool, so I'm going to go with TypeScript. And it's just creating a bunch of stuff, much like Terraform, much like Pulumi. They have a nice starter kit for insert your favorite language here. And once you do that, it makes this whole thing. Now, we don't really need to worry about all this. This is how your favorite language works, all the basic NPM fun stuff. Where it really begins is the concepts of stacks and constructs. So since it is built on AWS CloudFormation, and since it is targeting specifically AWS, this is where the superpower of customizability comes in. It's going to map directly to AWS resources. So if you're already in AWS, this is where you get your superpowers of, well, we have this abstraction that's kind of like this, but not like that. Nope, you're just building literal AWS things. So you have your CloudFormation stack, which is a collection of resources for a specific purpose on AWS. In here, you can have your constructs. You can have your lambdas. They even give you a nice queue example. How nice of them. For our case, we're going to keep it real simple, and we're just going to drop in a little lambda and a bucket. So we just bring the rest of it in. Typing would help. So this is all you really need to do to define some serverless code, right? So you bring in your Lambda function. We're being lazy. We're defining it inline, but I'll show a more competent example later. We're making it executable by URL, and we're saying, hey, give me this function as an output. That's all you really need to do. Much like the other options, it has, of course, its own CLI with 5 billion options. Thankfully, you don't need to learn most of them. You can just CDK deploy, and it will take your instance, use your credentials in your AWS, and deploy the stack out there. Now, behind the scenes, what it actually did was it created a CloudFormation template, which I'll show later. But much like the other two, it does plan out its changes, right? And it tells you, hey, you're about to create a thing. Of course, we're going to allow that. If there was a modification, it'd say, hey, you're changing a thing. And if there was potential for deletion, Since it is native to AWS, you're getting everything that AWS can give you, which sometimes certain providers don't give you as much control with Terraform or give you that fine-grained access. So when you're building very mature, very in-depth, or you just need to use that bleeding edge AWS feature, it's right there because it is AWS native. Now right now it's actually creating the resources in the cloud, relatively straightforward, making a stack, going through all that progress, and it'll be done in a few moments. And while that's done, I'm going to not finish speaking because it was that quick. So if I click on here, go straight to it, we deployed a Lambda. Ta-da! Thank you. Now, what it did behind the scenes, I said it created a CloudFormation template, which, for those who don't know, is basically the native infrastructure as code way to interact with AWS. And you can see that at any time by running synth. Now, it did this for us, but if we run this now, we'll see if we wanted to not use CDK, we just wanted to write plain old CloudFormation code, we'd have to write this giant YAML file minus the inline code. We have to write all that inline YAML file, which is cool, but then in this example, there was no conditional logic. There was no parameters. There was none of that. The more you do that, the more that YAML file will grow and grow and grow and grow. But with CDK, you don't have to worry about YAML file. It's like a C developer worrying about the assembly. I don't care what assembly gets generated, it just works. So to show a bit more, the final bit is where it really starts to take off, and I brought that with us, is showing the composability of it. So I'm going to show an existing, very amazing, highly complex, it's not really, it's very simple, full stack application. API and front end. This is the power of CDK and CloudFormation, but nobody wants to write CloudFormation, you just want to have it. So you are able to make custom constructs that do whatever you want. So you can bake things into the single responsibility principle. The API construct here just wrote native TypeScript, fully typed out, so didn't have to run this code and watch it fail. And just made a Dynamo table, made some functions. Instead of forgetting to assign a permission to a role, to a policy, all these lovely convenience methods that build that template behind the scenes, very declarative. You just write it and it works. And since it is independent like that, you're just like, nope, the API just has that context and scope. Similar for the front end, also just narrows it down to the responsibility that matters. Similar to Terraform and Polemy, it has some ability to fully customize it. That's where the levels of constructs I talked about. For anyone who's an expert in AWS, you'll notice a S3 deploy bucket deployment is not a native AWS CloudFormation thing. That is a custom construct that they made so that way you can easily do common patterns. This is, of course, just showing off the expandability and customizability of CDK. You can build it, they've built it in default, but then you can also share, right? So a lot of enterprise organizations have their own version of CDK on top of the actual AWS CDK using common best practices and everything they want. So look at this code, it's like 100 lines here. It totals up to like less than 200 lines for like a real mature application. And this works beautifully, but if we were to look at the counterpart, which would be a CloudFormation template, 400 lines. All of this, you gotta write all this manually. Some weird cache IDs, you have to figure that out. You have to do all this yourself. Oh yeah, these were terrible looking. But you don't have to worry about physically writing this because it generates the same output for you here. And since you're using your favorite language, TypeScript, whatever that is, you have full autocomplete, full accuracy. Oh, I just missed a W. I sure hope my code still works. CloudFormation's not going to tell you that without some strict and heavy linting. The last part of the equation, my favorite part, is the testing. It's just code. So you can run it just like code, and the same assertions you would ask of a human of like, hey, is that CloudFormation template good? Since the output is a CloudFormation template, you can make those assertions. Hey, is this property I passed in here? Do we have the gets? Do we have the posts? Are we passing environment variables here or there? Without having to deploy it and run a smoke test or a full stack or an end-to-end, you can just write tests, which means, I know not everyone's on board with this, you can do test-driven development so you can know exactly what you are doing before you do it, and then you don't have to spend forever writing infrastructure to be like, I don't know, I sure hope it does the thing. Well, you got all green tests, so it does the thing. That is all I have to say. Any questions? Yes.
From a deployment perspective, if you were to use CDK to sync the template and then use the template to deploy, what features would you be missing out on from not using CDK deploy and rather using like the normal ABS confirmation?
Yeah, so there are a few convenience features you would lose out on and have to manually handle out yourself. So this is make sure this is visible. This is the output of the template. So it actually outputs the template in JSON format. It's the same thing I showed in YAML, but it also does some convenience methods that I showed with the code wasn't inline and the S3 content was being included. It automatically does build bundling using some Docker images and stuff like that to build these asset folders for whatever you're bundling together, and it automatically handles shipping that up. You can get similar functionality with AWS SAM, which is Serverless Application Management, which is another infrastructure as code thing built on top of CloudFormation, but it gives you similar benefits. So if you wanted to just take this template and deploy it manually, you could probably get it to work, but there's no real advantage to doing that separately from the CDK command itself. Yes?
Are these each of your favorite tools, or did you draw out of a hat?
This one's my favorite tool, personally. I don't know about them.
Yeah, Pulumi's my favorite.
I'll say Terraform's my favorite, yeah.
Hey, we all got what we wanted.
Also, I don't know if you guys remember, but a few months back, Lauren presented on CDK TF, which is, I feel like, kind of a little bit of Pulumi, a little bit of CDK. But I don't know how mature it is.
Yeah, I was also going to mention it. It's relatively mature. Like, I was able to use it to spin up some stuff. At that point, yeah, if you want that weird combination of requirements, or actually unique, not weird, of requirements, it satisfies those, right? There's enough people with them that the library exists, and it's got a pretty strong base.
One of the nice things I think about like CDK, Pulumi, or CDK TF is if you're writing your app code in Python, you could just use Python to create your infrastructure as well. So if you're a developer that's familiar with Python, you don't have to go learn HCL or CloudFormation template format, that type of thing. So.
Yes, way in the back.
CDK's tied directly to Amazon. Is there an equivalent of CDK for Azure?
That, I believe, is Bicep, right?
It's not one-to-one, but it's pretty close.
Any more? Yes, sir.
Okay, so 10 years pass and you haven't looked at any of this code and you've got to open it again. Will any of it work?
Will any code work in 10 years?
So that's the interesting question, right? So when we were watching the first presentation, it got crazy. Oh, hey, these guys have already taken this offline, right? But they might be putting it back online. And from my perspective, I'm always worried about, well, what happens in 5 years? What happens in 10 years? Can I hire somebody that won't know how to do this in 10 years? Will any of it still work? Is the infrastructure still possible? Do I need to like copy a version of it in the States? Right? And that's what I'm kind of curious about. Is there anything that there's a company that's saying like, hey, we're guaranteeing this for 5 years, 10 years, as like say Red Hat would do, right? They say, give me a window of and that's what I'm curious. If this one's all Amazon, is it better supported than say Terraform?
Yeah, I will say that it will get the latest functionality of AWS quicker than Terraform, right? Or it might have the L1 constructs, which I didn't necessarily show off, but it allows you to do everything at almost a template level where you are physically defining every single piece of code. It gives you that power and that flexibility to tie in to what the latest of AWS, the platform. So yes, but I will say in 10 years, will this particular thing still work? Well, we have versions penned, right? But when AWS starts depreciating certain services, I don't think the Terraform will still work either, right? Like that will need to be updated to point to the new things or all of it, right? So I don't think so.
I was gonna say, I feel like AWS is pretty all in on CDK because a lot of their examples are, CDK examples and things like that. So
Yeah, it's
pretty well supported.
it's a first-party tool. So if the open source community or whatever community that were supporting it were to lose passion, it's not going to go anywhere, right? It's first-party, supported by AWS.
And at the end of the day with CloudFormation, what's happening behind the scenes is just they're calling their own APIs. They're very good about making sure those are backwards compatible and not breaking things. So I would agree with Joseph that I feel like this is probably fairly stable, whereas like, I don't know if any of the other ones would be, but.
Yes.
They probably stop supporting your Lambda environment before that 10-year period.
I would agree. Yep, Node 22 would get dropped before Lambdas in general or that CDK code.
I haven't put it in for about 4 years, and I feel very comfortable jumping back in today. So it hasn't changed that much.
There we go.
One other thing I think too is I feel like when CDK was first coming out, there was, or like a compelling reason to use Terraform. AWS provider was like, oh, you always get the features way faster on AWS with Terraform. I feel like now it's kind of like more equal, where like CDK is pretty up to date right away.
Yeah.
Worst case scenario, you're going to get an L1 or an L2 construct, which is the very low level resource, and then later on they'll do the L3 one with all the niceties. But there are some cases where CloudFormation, even just aside from CDK, doesn't support itself. So like one example is AWS Storage Gateway. That is not supported as far as I know in CloudFormation, which is an AWS service, but it is in Terraform. So like you have trade-offs with things like that. So
Okay, I will hand it back on over.
thanks again, Eric and Joseph. And we've got an interesting screen there. That's probably just Joseph's thing. One last quick announcement. The next meeting, October 22nd, I think we're going to try to get Jaideep to come and give that talk for local development stacks. Otherwise, just keep looking at the meetup.com site. That's probably the best place to get your updates on what the next topic will be. But otherwise, feel free to stick around, grab some pizza. Any questions for any of the other presenters or anything, let us know. Come up and talk to us. But yeah, thanks everyone.